Welcome to my very experimental SharkFest session. Experimental in a way that it is a double slot kind of thing, so I have twice the time to bring too much material and not get finished with it. Actually, what happened was that I turned in 2 talks for SharkFest, and Janice said, well, only 2? Can you do more? And it was back in December, I think, and I was totally exhausted from all the work I've done, so I said, I have no topic right now, but give me 4 slots and I think of something. So she did. I got the 2 that I already had, and I got 2 more that were blank, basically. And that usually never happens if you go to a conference and you said give me 2 blank slots. They were like, nah, we need the agenda, the abstract, and everything. So I got the 2 empty slots, and then I thought, well, maybe since last year I was doing the TCT advanced stuff, and one of the feedback things I got was, hey, cool session, but way too much material, or I think the official, or the correct wording was, instructor needs to look at his time more like getting things done in time. So that was basically some sort of criticism. And I thought, well, if I got twice the time, maybe I can make it so that I finish in time. So we'll see how that works, because I know how long 1 slot is, but I have never done 2 slots. So it may be that I finish very early or again late. We'll see. On that note, if somebody of you was in Christian's talk just now, please do the feedback thing at the end, because I think we forgot to mention it. I will try to remind you at the end of this session to do the feedback thing too. All right, so my name is Jasper. I work with Wireshark, Defense and Space, which is military and spacecraft things. I'm more of a cybersecurity guy now, which means that it's network forensics, and that means I'm looking through tons of packets to find the bad stuff. And very often what happens is that you have to tackle the Haystack, just as you do very often with normal network. This Christian already mentioned some of the Haystack sizes we had to deal with, and I haven't had them on slides. So the last couple of network analysis and forensic sessions I've done are roughly on 300 gigabytes in size each. And it gets very different from if you're opening a single file that is 10 megabytes or 20 or maybe 50. If you're dealing with, and we had the largest one at 4 terabytes, you need to have a plan, or at least what will happen is you will learn to model the plan during all the fails that you will encounter during looking at them. And so that is what I use as an inspiration to do this talk. And I will try to keep things interesting, even though I have to start with a lot of PowerPoints, which I usually don't do. My usual PowerPoint presentation are just 3 slides like hello, Jim, and thank you. This time I can do that. Okay, so by the way, if there are any questions, just ask. I try to repeat them for you so that you can hear what the question was. If I forget that, please remind me, because otherwise the answer may be cool, but if you don't know the question, it's kind of like one-way ticket. Okay, so first of all, what's a haystack, by the way? We will talk about haystack sizes and get through a couple of examples. Then what you need to think about too, maybe you didn't even think about this, but the capture process, the procedures doing the capture is quite important if you know that you're going to be hit with tons of packets, and you need to make sure that you're not capturing too much or too little. Usually when it comes to haystacks, it's more like how to avoid capturing too much. Because in earlier times, like 10 years ago, our usual way of capturing stuff was like, get everything and sort it out later. That way you can just drop the stuff you don't need and just go through the stuff that you do. But the problem with that is that if you're talking about terabytes and doing that with T-Shark, Wireshark, and other free tools that are not like optimized in dealing with that like SPH Shark thing is, you have to spend a lot of time of sorting away the stuff that you didn't need in the first place. So if I do a 4 terabyte capture and then realize, oh, I only needed 1 terabyte of that, throwing out the 3 terabytes will take so much time that I maybe should have done it on the capture already. Yeah. So I will give a couple of examples on that. Then tools. Tools means basically that I'm taking you through the tools that I'm using, and you can decide if that's okay for you or if you're using something else or whatever, but I want to show you if I deal with a lot of packets, what do I do? And then you can see if that works for you. And then of course I have demos and scenarios, and we will see how long they will take, because I have no idea. I will see. So I brought tons of stuff, probably way too much again, but we'll have to see. Good, so what's your haystack size? And that basically means, what's a haystack for you? Because a haystack for me is different than it is for you. So maybe this. Yeah. This doesn't look like much, but believe me, when we were teaching Wireshark classes, we had sometimes traces that were like 2 megabytes in size, and people could spend hours on this just to find the needle. I mean, this is kind of obvious in this figure, but there can be very small haystacks and you're still spending so much time on finding the right things. It may be a problem for you. Well, somebody else is like, this is simple, this is your needle. Yeah, so it depends on a lot of things, how big the haystack size is until it hurts you or until it gets tedious to go through. Maybe it's like this. I mean, this is not even hay, but it looks cool, so and my favorite one is, of course, this one, because it's in packets. So it's already nice, and well, at least this is how it's done in Germany. I don't know about the US or so, but ours are packaged, sort of. And this can be a problem. If there's a needle in there, good luck, because you need strong magnets and a lot of time. Yeah? So it all depends on your skill, your expertise, the tools we have, the automated expert software that can point you to the right thing. So there's a lot of aspects to how soon you can find the needle in one of those stacks. And this is basically one that I'm going to talk about. Okay, so this is my haystack size. If I see one of those, it's like, uh-oh, Christian, do you have anything to do? Good. Come with me. Let's fill the T-Shark, do the runs all through the night, and very often they run for days. So you need a plan. So, okay, so new analysts may find 20 packets too hard to understand. Others can deal with gigabytes of traffic if they have to. And also there's the question of, do I have a single file or do I have file sets? Single files means I give you a 20 gigabyte file in one piece. The problem with that is you can't even open it in Wireshark probably because it will crash or tell you something like, oh, out of memory. Yeah, so, and you don't even want to have the load time for this because everything above a couple of 100 megabytes just takes forever. It's getting better all the time because the core developers are really working on that and improving all the things to deal with the ever-growing amount of packets that we see in our daily analysis jobs. But of course, it's still a problem. Yeah, so you need a strategy for, okay, am I going to have a big file or many small files? But you can get around that because you can chop the big files into small files and you can merge the small files back into the big files. But it's not that easy because it takes time. Yeah, so if you have a 4 terabyte single file and you're like, it's easy, I just chop it into small files, that process will again take maybe hours to do. So you need to know that you have the time to do that. Very often you don't. Okay, example sets for me and some of them also for Christian. In October I had one with 300 gigabytes where there was a CAT design issue with Citrix. For those of you who ever heard how Citrix works, you may be surprised that somebody is doing computer-aided design, meaning 3D drawings in Citrix. you can do that, and what happens then is that on the server side, you have powerful NVIDIA graphics cards pre-rendering what the user is going to see on the other end, and then video files basically are transferred to show the result of the rendering. So if you're having interactive work on 3D models, all the clicking and turning and selecting is always going back to the server, the results get rendered, and it comes back to the user. So that is kind of crazy, but it works most of the time. And from this being an example set here tells you that it doesn't always work, because otherwise nobody would call me and ask, like, can you help with this? So that was a big one. This one was even bigger, and maybe the line below the size of this, and from your laughter I can tell that some of you got it, could tell you that this is maybe even harder than the first one, not just because of the size, but if somebody hands you 500 gigabytes of trace file and tells you, like, see what you can find. Like, seriously? I mean, 500 gigabytes, do you know how much that is? Yeah. So I'm going to work through some of this in the examples I brought. I analyzed them, of course. But a task like this is interesting because you can basically do whatever you want. But in the end, if you go back to the customer after a week of looking through traces, and you're like, found nothing, they're probably not going to be happy, because there is no network with no issues. There's always one, but how do I find it? I mean, I could do the scrolling packets kind of thing, but it's like, I don't know, a billion packets or something. My finger would probably fall off from all the scrolling with the mouse. So this is kind of hard to do, and 500 gigabytes also is something where loading all of that into Wireshark and say, hey, TCP/IP with flags, please. It's not going to happen. Yeah, you can't do that, because opening like a couple of thousand files in Wireshark, one after the other, just to get the flag state or even T-sharp in this, is a problem. Yeah, so this one was tough for me, because I was expected to find something, and I was like, how do I do that? Okay, next one. A bit more. This was about, I think, 600 gigabytes. You have to keep in mind that this was a slice capture, so we only took the first 256 bytes of each packet, and it still was 600 gigabytes. So if you see that, it should tell you that it was much more than this, but in the trace files we ended up with maybe 600 gigabytes. Yeah. Web application trouble with a long proxy chain, basically meaning the client is asking a proxy, which is asking a proxy, which is asking a proxy, which is asking the application server. And that cross-country and with encryption and everything being HTTPS, so interesting to find problems in there, because the connection from the client to the proxy is terminated on the proxy, so you're having a TCP session between the proxy and the client, but the proxy will start a new one and very often start a multiplexed one for all the clients asking you for the same destination, so you have the queries between the client and the proxy suddenly in multiple TCP connections in one big TCP connection, and you need to find all those. And with encryption, that is really tough, because you can only sometimes guess which connection from the proxy to the next proxy was triggered by the one that it got on the other side. So this is like, could be this, could be that. And very often we ended up with Christian finding something on one trace, and he's telling me, like, I found this, can you find the other connection going out in that time frame? It must start after what I found, it must end before what I found. Can you find it? And I was like, okay, this, not this, not this, not this, this probably, no, it is, it's going to the wrong direction. So also this can take quite a long time. Yeah. And then our favorite, 4,000 gigabytes. Check for indicators of compromise means, is there some Chinese guy in our network doing stuff that he shouldn't? Or a Russian guy, or maybe even a German guy? Yeah. So somebody coming into our network doing something, and check if you can find something. That also is very similar to this one, because you must have an idea what you're looking for. Otherwise, you can say at the end, like, found nothing, no save. And that is a problem because here, this is not just something we can improve and fix, this is something that is really critical because it can backfire. If you find something that is obvious, or didn't find something that's obvious, that's not good. Okay? So these are the last 4 projects I worked on. And this is the reason why I chose to do a talk like this. Because I ran into so many problems that I thought, well, I could tell about them. Good. So, working with the Haystack. First of all, what you need is knowledge. Knowledge is not easy to get because you have to read up on stuff and you have to consult documentation of protocols, of applications. You need network diagrams, you need an idea which IP does what on what port, especially if you're looking for security trouble where something is happening that should. You also need to know about application behavior, user behavior, and when I did the Citrix 3D drawing thing, basically what I did is go to the site where the user was working on his terminal to see how bad is it really. Because in my experience, very often users are like, oh my god, this is unusable, it's so slow. And then you're right next to it and you're like, what's your problem? I mean, it seems to work, right? Yeah, that's only today. Only because you're here. By the way, that happens quite a lot. If I go on site and I do troubleshooting, somebody tells me like, okay, we need a job, we can put a chair right next to the circuit for you to sit on. We give you some, I don't know, comics or something, just sit there because then it works. So that happens quite a lot. Alright, so user behavior is something that is very important to look at because you need to know what he's done, and if you're doing a capture and trying to find the packets that correlate to the user action, it's always good to have an idea what he was doing, because otherwise it's like guessing what might have happened on the screen while you're only having the packets. And then, of course, typical network and security devices like firewalls, packet shapers, and so on, because they are doing something to the packets in the network or on the path through the network, and you need to know what they're doing, how they work, how they may behave, what kind of special settings they have. And I mean, knowing that always helps. But the more important one is experience. And the problem with experience is right here. Usually gain it after you needed it most. So, in that moment where you needed it, you didn't have it yet. Because you learned it right after you needed it. Because you needed it. Or because you needed it in that place. So, there's no, let's say, quick way to gain experience except failing probably, or doing things, trying things, and accepting that you will fail. And that is how I and most of us learned how to do network analysis. I remember that I've done a network analysis in 2004 maybe, where we found a problem in a financial institution, and we had the right result, but our path to that result was completely wrong. So by sheer luck we found it correctly, but our argument of getting there was not correct. And that is something that you can only learn after a while, that some things should work this way or that way. And sometimes, well, you need to try to find the reason, and not always does it work. So if you have experience, the greatest benefit is that you can spot the important stuff faster. Very often if I look at trace files, I just skip over packets because I don't care. Yeah? One of the famous things for me being the sniffer back in the day telling me like window frozen. If you tell me window frozen today, I'm like, I don't care. If it gets to 0, okay, give me a call, but window frozen is like, I don't mind. Yeah? So there's the experience bit of me knowing that this is not important at all, but new users of a expert system may be like, oh my god, the Windows froze, what do I do? How can I fall? You don't, but it's not a problem afterward. Okay? So experience is a problem because you need to get it to be able to work with larger and larger amounts of packets. The more experience you have, the bigger you can tackle, or bigger haystacks you can tackle, or the more time you need to tackle it. And if you have an infinite amount of time, you can basically work through any haystack, but usually you don't. You get a couple of days maybe, or maybe even hours, or you have a huge problem where everything is standing still and you need to get a solution really fast and you don't have time. And then experience is key, because then you can really get to the solution fast. All right, this is a small example for you to take a look at. I've already shown it to Christian once, and I said, well, this is a funny thing. And he was like, well, that's simple, this is just that. And he was right. He was taking like a look at it for, I don't know, a minute maybe, or even 30 seconds. He was like, this is nothing special. Why did I pick this one? Because I think it's funny that it's saying Cincinnati Fin. Like, hello, oh, you want to talk to me too, but I don't want to talk to you. So this is how it looks like. And the question is it really happening? Is that the problem? Yeah, it's doing like Cincinnati Fin. There's a keep alive, okay, an act, and a reset. So is this a problem? Who thinks this is a problem? One? Only one? Who thinks this is not a problem? One, two, okay. The rest is like. This is not a haystack, by the way. This is just 6 lines of practice. So is it a problem or is it not a problem? It's quite unusual for a stack to say Cincinnati Fin.
Yeah.
Yeah.
That's weird. What's
weird.
What's the context of
This
this?
is basically from, remember the one where they said try to find something interesting? This is one of them. It was like, this is interesting.
Yeah.
But now there's the point of, okay, I found something. Is it something I need to mention in my repo? Or is it just nothing? Well, I can tell you what Christian said, and he's quite experienced. So if he says it's nothing, it's probably nothing. And this is nothing. It's not a problem. And it's just kind of strange. So, knowledge, once again, allows you to understand what the TCP packets are. You know what a SYN is, you know what a SYN is, you know what a FIN is, you know what a reset is. But that doesn't help you that much, because you're still here like, is it bad or not? And Christian's advantage is he has this, and he just said, well, it's nothing. Basically what happens here, and that is a really funny thing, and that's why I kept this in my interesting traces folder, which is growing all the time. What you have here is a SYN, ACK. This keep alive here is not keep alive, it's the ACK. And the funny thing is, it has the same sequence number like this one, because there's no data transfer in the process. And so this ACK packet was overtaken by the FIN packet. So on the wire, they just switched places. So one arrived sooner than the other, and the sequence numbers were so, by coincidence, so good that they matched like, it's looking like a Cincinnati Fin kind of handshake. It isn't. It's just a packet that overtook the other. Do you think there's any way to prove this, that one packet was just swapped with the other on the wire? Can I prove that somehow? Because the timing is not negative. Very often we have negative timings or something like this happens, but it's positive. So the packet order, this packet order is how it arrived at the capture device. So how do I prove that the keep alive is in fact the third packet for the handshake? IP ID. So if I would open the trace file and would take a look at the IP ID, you'll see that the packet here is one less than the FIN packet. So you know that the fourth packet has been sent earlier than the third packet from the sender. And so you know it's just a case of packets overtaking each other or passing each other on the path to my capture device or the receiver. Yeah? So this is a very small example of when knowledge and experience is quite a difference. You can know what is happening, but experience will tell you, I don't need to worry. Yeah, because you're looking at it and saying like, okay, because that's basically what Christian did, like, what's so interesting about it? It's just a packet out of water thing. Like, yeah, you see it, but I bet you a lot of other people just don't in that time, not that fast. All right. So everybody got what's happening here? This is not a problem because the people live, in fact, the third packet for the handshake, and it was just swapped on the wire and kept in the wrong order. That's basically what happened. So not a problem, it's just a very short connection. The interesting thing, of course, is still that it's doing a connection and then tearing it down again, but that happens often if you have something checking, like is the port open, like a monitoring system, testing if the system is still up, at least the port is still up. So stuff like this I see all the time. This is not even a scan from someone bad, it's just like a Nagios or a Singer or whatever system, like testing port open, okay, no other necessary. All right, so the path to experience. If you have no experience or just a little experience, you can still use knowledge to reduce your haystack size. It's much more complicated because it doesn't just get to you like this, you still have to read up on it. But you can read documentation on protocols, applications, you can read forums like the Q&A page of Wireshark. Who's ever used the Q&A forum on the Q&A page, the Wireshark Q&A page? Really? Who didn't know that there is a Q&A page? You all do, but you don't go there? Okay. Well, if you have a question where you are unsure if what you found is correct, you can always ask a question there. Very often, somebody will help you when there's time, or when somebody knows the answer, of course. And you can get additional help from someone who's probably more experienced in this kind of thing. Yeah, so, read documentation, get help. Of course, also get information about IPs, ports, users, which is sometimes very difficult for me because I usually come into a company where I don't know any of this. So I need the help of network administrators and other guys to tell me, oh, this is just our proxy doing this, that is fine. Because sometimes things look strange otherwise. And very often, you will need a detailed problem description. Not just, yeah, it's slow, because then you're looking through thousands of packets and don't have an idea what you're looking for. So a detailed problem description is always an interesting thing. The last job I did, I told them, okay, if we're going on-site and capture, I need the five most pressing problems described in great detail, and they need to be reproducible because I only have 1 day on site. And very often what will happen is that the users say, well, maybe we don't have that many problems. Yeah, so before that they were screaming like, this is all bad, and then they're like, okay, we need to give you a problem description that is specific. Very often they back out and say, okay, maybe we only have 1 or 2 problems really. Very often you need to learn on the fly, so if you see something that you can explain to yourself, well, find out. Consult documentation, consult others, something like this, and double check your findings if you're not sure. Yeah, so I'm lucky I have Christian, so we can always like talk to each other and say, well, I found this, do you think I got it? And sometimes it's like, no, you need to do better than that. It happens constantly. Okay, general best practices. It's a funny thing that I thought about, like how many chess games can you watch simultaneously or play simultaneously? Can you do more than one at the same time? Who thinks you can play more than one chess game at the same time? I can't. Yeah. So what confuses me sometimes is how people try to read a trace file without like filtering on TCP conversations first, because basically what that means is you're looking at tons of chess games at the same time, trying to make sense of them and getting confused all the way. So if it looks like this, You have sniff packets everywhere. What you need to do is, and these are a lot of chess games right now, you need to filter on them and focus on single TCP connections because they don't have anything to do with each other. It doesn't make any kind of sense to try to figure out something in this screen because you will confuse yourself with all the packets that are from different conversations. There's a couple of ways that you can do this. So let me check. And I will use the Q2 bit of Wireshark until I'm too annoyed with it. So let's see how long that takes. I think I have something on my desktop. This one. It's just an example too. Like there's many conversations here. So what you can do is either use colorization so that the same packets of the same conversation get colorized, but still it's confusing and the delta times and other things may confuse you. So what I usually do is only colorize if I want to see interaction between related TCP conversations to see, oh, this one starts after that one and ends before this one. So for that, colorization may be good, but if I'm going into real troubleshooting mode, I always go for colorization filter TCP, like this, and then I can focus on the single conversation without being distracted by all the others. Either that way, or of course, and most of you know this, you can go for the stream index, which in this case is 9. So TCP.stream equals 9, looks like this. And basically you get the same results. But do you know when the stream index filter is not a good idea compared to the full conversation filter? When do I stop using stream index filters? Because it's shorter to write, if I know the number, it's really easy, but when do I use the conversation filter? And I'm going to use the conversation filter again just to show you how it looks like. I mean, you've seen the stream filter here. Now let's do the conversation filter again. This is how the conversation filter looks like. So it's going for the IP addresses and the ports. And if you write it by hand, it's much more work than TCP stream equals 9. But when do I use this one?
Multiple files.
Multiple files. Correct. If I have multiple files, like I'm capturing a conversation that runs for maybe an hour, and I've seen those in the last couple of months very often, like conversation running for days even, constantly sending stuff back and forth. And if you're capturing into files that are only, let's say, 500 megabytes each, you will have bits and pieces of the conversation in each file, but the stream index will be different. Because the stream index is calculated from the beginning of the capture that you're opening, so the first packet or TCP packet that is seen gets to 0, the second TCP packets of the different conversation gets 1, 2, 3, and so on. And it's only a relative number. So if you open the next file, the stream index number 9 can be a totally different conversation. So if you have a conversation that spans across multiple files, you need to use this kind of filter, which I call an absolute filter, because it doesn't care what file it is. It will always give you both IP addresses, both ports, and what's happening. So use the stream index if you're sure, like in this case, that the conversation is only in one file, but if it spans across files, you need to use the absolute filter. Okay? Yeah, question?
Also, if you're looking at an issue that might involve problems with port reuse, I think it does get reset after it sees another SIM exchange, doesn't it?
Okay, the question is about port reuse.
Yeah. So if you've got two servers that are talking to each other, they're very, very chatty,
Yeah.
and they're opening a lot of short duration connections.
So the question is, what happens with port reuse? Who knows what port reuse is? One? Well, I'm not looking at this part because that's all the specialists all the speakers and presenters and stuff. So, port we use. Time up? Using? Okay. Port we use means that the same conversation or pipe tuple, meaning source IP, destination IP, source port, destination port, and TCP or UDP or whatever it is used again. As most of you probably know, the client chooses an ephemeral port, like some number for each connection, and it increases it usually. It starts at, let's say, 49,152 for Windows Vista and up. It comes up to 64K, and then it starts at the bottom again. So if you have many connections, like opening tons of connections all the time, at some point the source port will start at the bottom again and count up and match one that you already have. And in that same moment, Wireshark will tell you port reused, because it's seen the same conversation, well, it thinks it's the same conversation, again. And if you do a filter like this, you will see both of them. Why? Because it's both TCP. Source address is the same, destination address is the same, source port is the same, destination port is the same. So Wireshark shows you two connections, not just one. What does the stream filter do? It shows you just one. The first or the second, depending on which number you use, because it will be increased with each new connection, even if it's using the exact same port and IP pair. Yeah, so the stream limits filter has an advantage too, because it can separate conversations running on the same port pairs and IP pairs, of course, or as we say, socket pairs. All right, so always remember, don't try to troubleshoot on unfiltered TCP conversation, because it's just not going to work. Yeah, always, it's the first thing I always do is filter the conversation and then look at it. That's basically the first step all the time. Now, something that where I'm not really good at is discipline is key. Basically, you never must, or you must not ever delete your original capture files, because if you're processing them and counting them and reducing them to smaller sizes that you can look at, it can happen that you did something wrong in that process. And when you end up with a small file set and something where you say, okay, I can load this into Wireshark and I can find something in there because it's small enough, and you find something in there, then you always have to go back to the original file and verify against the original again, because it could be that the problem that you're seeing was created by you filtering stuff. Now that is very important, because if you don't do this, you write a report like, I found a big problem, then it turns out it was caused by your filtering. And that is not a good idea. So even if you don't do this, never delete the originals in case you have to prove that the finding was correct. Sometimes I get challenged by customers telling me like, what do you know about packet analysis? What do you just turn in as a report is total not true? And then I have to prove that I was correct. And very often I need to go back to the original files. Okay, so that is important. There's more important things, like document everything. This is the part where I'm pretty bad at, because I'm like, I don't want to write down all the stuff that I'm doing, but in the end it always bites me, because if somebody's asking me like, how did you get there? How did you manage to find this specifically? I'm like, yeah, I did this, and then some magic happened now here. And that is not that a good of an answer, because very often the people are going to challenge you over it, because they say it's not our problem and you can prove to us how you got there, so we're fine. That's not good. So document everything, and it's very hard to do because laziness, especially mine. So very often I start writing down many things, and then at some point it's like, packet loss. in my log. Nothing else written. Okay, then the other thing, keep the filter chain intact. That's basically mean if you filter on something and then you think, okay, this is still too big, I need to filter more. Then I filter again, and I filter again, make it smaller, 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 smaller. You need to keep the whole filter chain. You cannot do any in-between steps. You need to keep them all, because if you want to find out how you get to the final result, you need to be able, like, and I always open subdirectories for this. So in the original directory, I have all the files, and then I call this next one filtered, or carved, or extracted, depending on what I did. And then the filter result go into the filter directory. And then I open another filter directory inside the filter directory, and so I have a directory structure telling me, how did I get there? It's somehow like the old sniffer where you had tabs opening right next to each other with each filter result, which was really helpful because then you could close them quickly again. So I don't need this. But we can do that in Wireshark. You only can have one file open at a time. So if you're filtering, save the results, open it, continue, but keep your chain. Now you need to be able to backtrack. Teamwork. This is not that easy because there are not so many network analysts in this world, unfortunately. I had the pleasure of working with 3 experts, myself included. Okay, I'm calling myself an expert, which is not that great, but let's say I know what I'm doing most of the time. Chris is working with me, and I had another guy working with us, so we were like a team of 3 guys working on complex problems. And that can help a lot because you can distribute the workload, you can challenge each other if you think you found something, and that is what happens all the time. And not all analysts are equal. If somebody comes up to me and says, well, I've got this weird problem with Microsoft Sys SMB file sharing thing, I'm like, okay, cool, sorry, but my knowledge about that is like this big. Or a voice over IP or Wi-Fi is nothing of my specialty, but I know how to do virtualization stuff. So we go into a big project, and there's VMware involved or something like this. I know what to do. If I need something done with voice over IP or Wi-Fi, and I can either do it myself, but not that good, or I have somebody who can. So that's helping too. And then there's the challenges. Yeah? This is actually a quote, basically, like, hey, I found it. It's like, nah, impossible. I can't be. And that happens actually almost all the time whenever we do an analysis. And what that does to me is like, okay, when I say I found it, I better should be able to prove it, because otherwise he will be right and saying you didn't get it. But that's always better than if the customer tells me in the end, like, what were you doing all the time? So we constantly do this to make sure that our results are correct. So whenever, even if Chris says, I got it, I'm like, nah, impossible. You're good, but not that good. And then he's like, yeah, but this is it, and that is right most of the time. So this is an important thing, and you shouldn't take it personally. It basically means that somebody is trying to find a loophole in your argument, and it's always better if somebody friendly does it than if someone unfriendly does it. And we're very often in unfriendly waters with network analysis, because basically we are working against the server administrators, client administrators, application guys, and whatnot. And the only guys that are probably happy to see us are the network guys, unless it is the network. Then they're not happy. But that's only 20% of the time, so others, the 80%, are more dangerous to us. So this is good too. If you don't have somebody like this, you can still try to ask a question on the Q&A forum. You should sanitize all your data, of course, first, or just double check your argument or line of thought. And very often, if you got something incorrect in there, we can point it out to you, just because there's experience enough to guess what you were doing and then help you with this. Okay, the most important thing of all, if you're working alone or together, is you need to focus. I was doing this challenge last year. It's called the Megalodon Challenge. I don't know who has taken it. Megalodon challenge. You did, Hansak tried it for a minute or two, Saki probably did. The biggest problem and the real mean thing about that challenge was that the traces were pretty big. They were like a gigabyte each or something. And there was so much stuff in there that had nothing to do with the problem that it was easy to get distracted. And almost everybody did. I was getting questions about things where I'm like, I'm never looking at that. I never looked at that when it happens because it's not important. So if somebody telling you, I have this problem between those two IP addresses, I look at those two IP addresses, nothing else. Unless looking at those two IP addresses tell me like, there's something else going on that I need to look at. If there's nothing else going on, I don't look at anything else. It's just, okay, these two I need to analyze. Now that is very important because we're all, or at least myself and Christian and Hansak probably too, we're all like kids in the candy store when we get into packet trays, like, oh cool, what's in there? So we drift off in all directions and try to find cool stuff. But that's not what we're there for. You know, we need to find the problem, so we need to focus. For a big team, we also need a team leader, because if everybody's working on the same, let's say, conversation, and everybody's like, hey, I found this problem, and the other one says, well, I found that too, why didn't you two spend time on this? That's not a good idea. Because if you're working with multiple persons on the same thing, you need to distribute your workload, of course. So you need a team leader that assigns tasks to members, keeps track of the time spent, because that will be billed at some point, and you can't go in and say, well, we needed 3 times the time than we used to, or that we promised. So somebody needs to keep track of time, and you need to do status updating things. And those need to be really short. Usually what I did with my teams always was like, okay, who found what? Then we quickly gathered them, and then we decided what are we going to investigate next, what needs to be checked, and what can we ignore, and then continue. Like very often, half a day of the time frame is our smallest limit. Like, okay, this morning I will do this, Christian will do this, and Eddie will do that. And then at lunch we get together, like, what did you find? I found this, I found this, I found this. Okay, based on that, you're now going to do this, I prove that, and you do this. And then we continue. And that is the quickest way to get somewhere. It's basically like software development, like an Agile or Scrum or whatever it's called thing, just with packet analysis. Get together quickly, get a new direction, decide what to do, and not waste time on meetings. Well, we all do that way too much anyway. And for the biggest ever analysis we did, I think it was 2 weeks with 3 people. The first thing we ever did when we got the traces, and I think we were capturing for 1 or 2 days, and it was half a terabyte or something, we deliberately said the first morning of the first analysis day is, can you stop time? Do whatever you want, look at the traces, look through packets, filter on whatever you want. Just get it out of your system so that you can focus afterwards. Because we knew if we didn't do that, it would happen all the time over the next couple of weeks. So the first morning, everybody was like, hey, this is cool. No, it's not. Oh, this is cool. Yeah, maybe we need to look into this later. And everybody could just open whatever trace file you wanted at any capture location and just have fun with it. And after that, okay, focus again, do the job. Okay, so what are you supposed to do? And here, more information is always better. If somebody tells you, like, here's a terabyte, find anything you want, it's hard to actually find anything because you don't know where to start. But if somebody tells you, here's half a terabyte or 4 terabytes or something, and we have a problem with those 2 IPs, then I'm like, okay, when does it happen? At which time? What's the application? Which port can I filter on? Can I extract anything? Can I look for ICMP messages for that port coming back and telling me there's something going wrong? That helps a lot. So if you're dealing with a lot of packets, you need additional information. As much as you can. There's not too much information on this. You still can select, okay, I don't need this and I don't care about that. But no information is a big problem. Because then you're like, okay, what do I do now? Markers, do you know what markers are? Well, sometimes you can not exactly tell when the user activity actually ended up in the trace file afterwards, because their time or their clock is incorrect, and very often you're writing down time is like, okay, the user did this at 1 p.m. and 14 minutes. And then the user did that at 1 p.m. and 15 minutes, which means you have a written marker that may not be the same like in the trace file because the clock is lining off. But a minute of capture can be huge. Sometimes we have a gigabyte in no time in a minute. So finding some packets in there just by the minute, very difficult. Yeah? So markers means that somebody's pinging something, or you're calling the website with a specific URL so that you can filter that and find the location in the traces so that you know, this was before we did this. And the guys from TribeLab, which are over there in the Shark Reef, they have a neat website that you can use to do that. You know, you can just click a button and they will inject the HTTP GET request with a number count that you can find later and find the location and say, okay, this is where I started working. It's really nice. It's free, and you just need to call their website and you can find it. Okay, capture setup. As I already said, it's important that we capture according to the problem. And there are some things to consider. First of all, what timestamp accuracy do you need? If you're going into a financial institution, they will care about milliseconds, microseconds, sometimes nanoseconds. If you're going to whatever other store, they may not care. So you need a capture hardware that can do the capture with timestamps as accurate as you need them. Very often I say, well, my notebook is just good enough, or my laptop is just good enough. Sometimes I need very specific timestamps, especially in one case I had lately where somebody says, well, we're moving applications from a mainframe to Linux servers, and it turns out that the application performance is really getting worse for all the applications that we are rewriting for Linux. And the guys think it's the network. And I was like, okay, wait a minute, because between the client and the server you have like 2 or 3 Nexus switches, that's it. Where do you think the time is going to get lost? Because there's nothing that could possibly be holding packets like a hostage, like you're not going to get there sooner than this. So basically I knew from experience that it was not very likely that the network was the problem. But to prove that, I needed to capture at both points, like here and there, with a network in between. And to prove timings, I needed to use taps, because otherwise they could argue that the spend port was doing something that I didn't see. So 2 taps it was. And I needed a precision timing on the capture. And what I did for this one is use one capture device that could record both at the same time. We needed a longer cable for this, obviously, because it was from 2 locations in the data center. So I think there were 2 20-meter cables involved. And it went on the same capture machine with a nanosecond resolution, and that way I had both captures in the same trace with a high precision, and I could tell them, well, your problem is not the network, because I see a transport time in microseconds, 1-digit or 2-digit number, I think, or even less, I can't remember. So it depends on what the task is, what kind of capture device you can use or cannot use. Okay, if you have larger captures, I mean, this one is really nice because it's, I think, a 4-digit number to purchase one of those, because they're really fast and expensive. They can write gigabytes per second to basically the storage. But how big are they? They're not pretty big, so maybe you need slower drives that are bigger. Or you need faster drives that are smaller, but you know that you can reproduce the issue, so you can work with this. And do you have enough free storage is something that you need to check before you start capturing, because otherwise you will lose a day trying to find more storage. Is it fast enough? So if you can't afford to have packet drops, you need to have fast storage. And which file format are you going to use? Basically, my normal answer would be, well, go with PCAPG, because that's the best file format that you can use. And I really like it because it's really flexible and you can store as much information as you can get. But if I know that I need to carve information from the file, that would mean I need to use a program that can understand PCAPG file format, like T# or Wireshark. well, it's basically going to be T-Shark because I need to automate it in batch code. But T-Shark is not fast. So it will take hours and hours to filter something. And maybe I can use TCP-dump instead with a BPF filter, which is 100 times faster sometimes, depending on what you're doing. If you're filtering on a single IP with T-Shark, I think TCP-dump is like 100 times faster than this. By using BPF filters, looking at offsets, and just being able to count much more quickly. But TCP-dump doesn't understand PKG, at least not in earlier versions. I think the latest can do this, but if I use an early version or I'm using Windows a lot, there's only WinDump from years ago and it doesn't know about PKG. So I need to have a plan of what I'm going to do, and that may decide my capture file for me. PKG is fine, but if I have 4 terabytes of PKG and I want to filter fast, I need to convert it to PCAP first, which means I need twice the storage, and I need to wait until EditCap has converted all the files for me, and that can take hours. Do I have this time? Well, this is a problem you don't have if you're just working with small capture files, but if you're talking about 54 terabytes, converting them can take hours. So that needs to be considered, and it's best to consider this before doing the capture. Okay, then the other thing, and this is actually one of the devices I was using like until end of last year when it broke down. It's a network general capture device that could capture up to 4 times full duplex encrypted Ethernet. It's really nice, but the problem is that the IDE drive inside is so slow that you can't write without packet loss, not for a long time at least. So I'm not using that one anymore, but the biggest problem of this one is, okay, how can I access the captured data during the capture? Because often you start a capture and it runs for a day or two, or maybe even a week, and you don't want to wait until the end, but you want to access some of the data in between to start analyzing on what you already got. But how do we get the data? Well, in this case, you could use the USB port, but it's only USB 2. And if you use an older version, it's only USB 1. So copying packets from the disk with USB 1 is an experience that you don't want to have. Believe me. I mean, you're all old enough, I think, to have witnessed how fast, or not fast, USB 1 is. But the older device I had, well, that was a nightmare. So I started using the 100 megabit port to copy stuff off because it's much faster. And this one has a gigabit port. But then again, this may hurt your capture performance because now the disk is doing 2 things, writing packets and reading packets at the same time. And that may lead to packet loss that you can't have. So all these decisions are important. You need to know if you can afford packet loss because of your starting early, or do you have to wait until everything is captured and then start this. So, yeah. USB 1 is ouch, this is main, and this is yay. Should be a gigabit. Or what I did in the end was I basically pulled the hard drive from the device and used a adapter to access the hard drive directly because it was so much faster. Signal file set. I already talked about this one. If you're doing file sets, well, you can open them one by one in Wireshark, which is quite nice. If they are labeled correctly, Wireshark will even allow you to open them via the file set menu. I don't know if you've seen this one, and I'm not sure if it survives the move to T-Shark. There's this file set kind of thing. And you can see that list files will show me nothing because there is no file set right now. But if you do a dumpcap capture, you will have noticed that dumpcap adds a timestamp to the file name. And if Wireshark sees this and it sees, oh, this one is called capture 1, and then the file stamp capture 2, another file stamp, it will list all of those in the file set. And then you can open them just by clicking on them and open the next one really quick. And so that is maybe helpful if you want to go through the mechanism, which I cannot recommend at all. So, if you have a single file, all the details are shown in Wireshark at once, but it may be too big to load. Very often that's the case. You cannot load anything, I think, above maybe 4 gigabytes. I never tried, but I think I went up to 4 gigabytes, and that even takes minutes to open, so very often we don't. But if you have a big file, you can still cut them using edit cat. The -c parameter or -c parameter allows you to specify how many packets you want in each file. So if you're doing this, you will end up with a file set basically. So we can try that. So I think this is one that I cut with edit cat. The original file was 34 gigabytes, I think. And then I used edit cat -c 100,000 probably. And you end up with a file name just as if you've done the ring buffer capture in DuckTag. So now I can open them one by one. If I go there, we should probably see that then the file set menu is working. You can see down here it's loading. This is 256 megabytes. Just to give you an idea how long it takes to open this from an SSD in this laptop. So there it is. And now, if I'm not mistaken, the file set should be able to. No, it doesn't. Okay, maybe this is the one that's not working in the GT yet. Let me try with the legacy build. In case you didn't know this, the new Wireshark version will also still install the GTK version. It's called Wireshark Legacy. And I quite often use it. Because sometimes things work in there that don't yet in YouTube. And again, we wait. And again, we realize how long it takes just to load a couple of hundred megabytes, which is not that much. Let's check the groups here. Yeah, now you see it's list files, and it will give you a list of all the files in the set. So if you think now, oh, I want to look at the second one, just click on it, and it opens. So that's the fastest way to go through files, but I can only recommend that if the files are really small, like a couple of megabytes maybe. Otherwise, it's not a good idea. Or you can use here file set. Next part of this. This works not too. Good. So, file sets, and Christian already mentioned that we use file sets between 64 megabytes and 512 megabytes because it's always a decision between how many packets I want in a file that are easy to look at when opening a single file, because if a conversation spans multiple files, that may be a problem because I have to look at all of them separately and recombine them by pulling them out and merging them back again together. So very often I go for a bigger file, but sometimes if I know I have to open them all the time manually in Wireshark, I go for the smaller one. So it depends on each situation, what kind of thing I use. The last 4 terabyte capture we did was 512 megabytes per file, because I already knew it's going to be huge, and I ended up with 7,600 files or something. So that is quite a lot. Slicing. Who knows what slicing is? Oh, a couple of you. Okay, slicing basically means that you're not writing all the bytes to disk. So if you see a packet that has 1,500 bytes, you decide that you only need the first 64 to get the Ethernet header, the IP header, the TCP header. So you basically omit bytes and do not write them to disk. This can be helping you with disk space. If you do not have enough disk space, you can do that. And very often, and that's something Hansan already mentioned, we are looking at problems at the TCP level. We don't even need the payload. So we can just strip it on capture. But it's important that you are sure that if you're doing this, you don't need the payload, Because if during the analysis you realize I needed the payload, there's no way to get it unless you build a time machine first. Because then you can go back in time and capture without slicing. So slicing is something where you need to be really sure that you don't need it. Very often I do slicing when I cannot decode the payload anyway. So if I'm capturing HTTPS, it often doesn't matter. Or if I'm capturing Citrix, where the protocol is proprietary and I can't read it anyway, I can just cut it away. Disadvantages, yeah, I already got this, and very important, which may be surprising for some, but if you're slicing, you cannot reconstruct content. More than once I've had people who ask me, like, why doesn't packet reassembly work? Why can't I extract something from the trace file? And then it turns out, yeah, well, if you capture it without all the payload, there's no reassembly, because Wireshark then has gaps in the data. It's like, I can't help it. So if you want to do reassembly, which basically means if you're doing anything forensic, so if you're doing network forensics, you need the payload, you cannot slice. Yeah? So forensic work means you need all of it all the time. If you're doing network analysis, performance analysis, troubleshooting, you may be able to. But it's important that you are making a decision on this, not in the end find out that, oh, I should have done it differently because I didn't think about it. Yeah. This is something that very often happens with TCP dump, because TCP dump in the earlier version was only giving you the first 64 bytes, I think. Now it does give you all. Okay, my analysis setup, or general analysis setup. Number of analysts, well, the more the better, but you need to coordinate, because they should not work on the same thing all the time, because that would be a waste. Number of workstations. The 4 terabyte work we just did involved, I think, 3 or 4 workstations, even though we were only 2 persons, because we had computers for us doing the calf jobs, running through the night, and we couldn't work on other things while they were busy with sorting packets for us. That is really helpful if you're having a lot of packets to have spare machines that you can run calf jobs on. Basically pulling packets by filter or something that don't slow down your system while you're doing interactive work. Problem with that is you need to make a plan how to get the trace files to the machines, because if you have 4 terabytes, even the simple copy from one disk to the other will take hours. So again, the time is a problem. Sometimes, if we can afford it, we just put all the traces on a big QNAP storage with a 10 gigabit link, and then connect from there or from our workstations to that central storage system and work on that. But for that, of course, you need fast network connections. Number of hard drives. I bought a couple of USB 3 external connectors for SSDs and SATA drives, just to be able to copy from one to the other. Because reading from one and writing to the other is usually much faster than reading and writing to the same disk. So that may be something that you want to consider. Often I prefer SSDs, but of course they're much more expensive, so it depends on how much you can spend. And then there's the famous thing of number of monitors, and well, basically the more the better. I started with 1, then I had 2, now I have 3. And each time my girlfriend said, why do you need more than 1? It's just, nobody needs it. And every time I bought one, after like a day, she's happy with it. Like, okay, I can do multiple things at the same time. Like, watch this here and serve there. For me, it's like 3 monitors, because why? 4 don't fit on my desk anymore. Otherwise, I would have 4. I would have constantly thinking about stacking them up on top of each other, because our security center operation guys, they have 6 monitors. 3 in front of them and another row on top. And that is pretty good. I mean, they don't see each other during the day, but they can see a lot of information. Yeah, so more monitors can help, and you shouldn't stop buying them if you can afford to have them. Okay, typical analysis tasks. These are the things that you need to do if you're finding haystacks. Calf and extraction jobs. That is basically the main thing that you're going to do. Decide what you need to look at, then create a batch job doing that for you, or whatever tool you're using, and then pull the packets from the source files into smaller sets, and then work on those. Yeah? And I will show a couple of examples. Chris already did that in his talk, but this is very important, and it can run for days. So very often it can happen that somebody says, well, did we look at DNS yet? And then somebody says, well, no. Yeah, then we need to carve again. And that can mean, if you're dealing with 4 terabytes, that can mean that you have to wait a whole night until the result is there. And because, think of this, if you're running a T-Shark job on a set of 7,600 files, you will end up with a smaller set of 7,600 files. They will be really small, but you will still have 7,600 files. What are you going to do then? You have to merge them so that you can look at them. Can merge 7,600 files? No, it can't. Because it will tell you command wrong, command line to wrong, whatever it is. I think the micro just broke. Yeah, good. Dead battery.
Yeah, there's time for the break.
It's time for the break?
Yeah.
Excellent. So have a break, and we continue at the time that the sect is supposed to start, and then I will do demos and then bore you with all this stuff, okay? So see you after the break.